So we find that if we have got an unregulated power supply, and unregulated power supply means some ideal voltage source with a non-separable internal resistance, so that point A and point B are accessible to us. This may be say 0.1 ohm, and if I want, so one thing, by using an unregulated power supply of X volts and by putting a shunt resistance in parallel with the load, and by having an arrangement which we said is being done by human yourself, right? So last time I said that you are inside and you are changing and now it will be made automatic. So by making an arrangement of shunt in parallel with the load, we can ensure that some voltage, fixed voltage, is available irrespective of change in load resistance. So by putting a variable shunt, obviously as it is shunt there is no need to say in parallel because shunt is parallel. By putting a variable resistance in parallel with load resistance, I can ensure that the voltage between these two terminals across the load is kept constant irrespective of changes in load resistance. Then we will say that it is as the ideal source, but it is not so, but within a stipulated range. Is the idea clear? By putting a shunt resistance, we can ensure that a fixed voltage is possible to be obtained. A fixed voltage is possible to be obtained, but in a limit, and such fixed voltage obtained so has to be, it means by using an unregulated power supply of 10 volts, you can't construct a regulated power supply of 12 volts. You can't construct a regulated power supply even of 10 volts. It has to be of value less than the unregulated voltage source, right? So the value or the rating of the power supply, which would be a regulated power supply. Regulated power supply means it is like an ideal voltage source within a range. It is possible that value should be less than 10. So if I say that I want to design for 5 volts, if I want to design 5 volt voltage source, design of 5 volt voltage source for using a power supply of 10 volt unregulated, and what I will take that 0.1 is too good, so I say 1 volt, right? So by using an unregulated power supply of rated voltage rating 10 volt and internal resistance 1 volt, I can construct a regulated power supply of any value less than 10 volts. I can construct for 5 volts, I can construct for 7 volts, and so on. What should be the formula? Formula is very simple, that it should give required voltage across this. Means this should be variable. Or what is the logic? RL parallel RSH must be equal to R. If it is 5 volts, right? 5 volts, because for otherwise, what is the formula? RL parallel RSH upon RL parallel RSH plus R must be equal to what? Must be equal means this voltage is, you want this to be 5. So this 5 is total 10. So this total is 10, and this V, or means what voltage? Suppose if you want it to design for 7 volts, then this should be 7. Is it right? So it should be 7. So R you know, RL you know, so you have to adjust RSH. लक्षात घ्या, मराठी सांगतो तुला एकदा. रेग्युलर पॉवर सप्लाय मध्ये आपण काय करतो, तर व्हेरिएबल आहे आणि तो असा व्हेरी करायचा की याच्या इथं व्होल्टमीटर टाक आहे, त्या व्होल्टमीटर बघायचं आपला व्होल्टेज किती पाहिजे, 5 पाहिजे. जास्त असलं व्होल्टेज जास्त असलं हा रेजिस्टन्स कमी करायचा, व्होल्टेज कमी झालं हा रेजिस्टन्स वाढवायचा, हा रेजिस्टन्स वाढवायचा. आणि इट हॅज गॉट अ लिमिट, इट इज गॉट ए लिमिट. व्हॉट इज द लिमिट? दॅट RL what is the limit of shunt regulator? What is limit of shunt? RL and R, there is a relationship. Suppose if this is 10 volt and this is 5 volts, or in general, in any case, so what maximum value this shunt resistance can have? Infinite. Means in case of no shunt, what will be the voltage? In case of no shunt, voltage will be, what is the formula? RL upon RL plus R into 10 VL, right? And if I want 5 volt, in that case, what should happen? This RL should not be less than R right now, because it is 5 and 10. Means in any, so there is a maximum load. Maximum load means minimum load resistance. जास्त load म्हणजे load resistance कमी. So there is a limit on RL, and this RL has to be, for this to function for 5 and 10, this RL has to be more than or equal to R. कळलं का कळलं नाही? So this is, again repeat, this is unregulated power supply, where VL will be equal to RL upon RL plus R into 10. Right? This is unregulated power supply of 10 volts. So as RL reduce, what will happen? By dividing RL in the numerator and denominator, we get 1 upon 1 plus R by RL into 10, right? So RL infinity means open circuit. What would be VL? 10. As RL reduces means as load increases, right? For electrical engineering, many times people confuse. लोड जास्त म्हणजे लोड रेजिस्टन्स कमी आणि लोड कमी म्हणजे लोड रेजिस्टन्स जास्त, right? So as load means from open circuit, as I go on increasing the load, putting the load, what are you doing? Hello, putting the load or reducing load resistance. What happened in this formula? When this arrow is infinity, this was not there, so it was 10. When RL becomes finite, this will be, when RL infinite was 0, but when it is finite, this would be non-zero and positive. So it is 1 plus something. So 10 upon 1 plus something will be necessarily less than 10, as long as something is positive, right? So as we load voltage reduces, it is unregulated power supply, right? Now what I intend to design a regulated power supply of say 7 volts using this configuration. म्हणजे मला काय करायचं आहे, 10 व्होल्टचा अनरेग्युलेटेड पॉवर सप्लाय, जिथे व्होल्टेज 10 व्होल्ट आहे, रेजिस्टन्स 1 ओम आहे, इंटरनल रेजिस्टन्स 1 ओम आहे, तो वापरून मला काहीतरी अरेंजमेंट करायचे आहे जेणेकरून मला 7 व्होल्ट सप्लाय मिळाला पाहिजे आणि ते 7 व्होल्ट कॉन्स्टंट राहिले पाहिजे. मग त्याच्याकरता लास्ट टाइम मी सजेस्टेड दॅट पुट ए रेजिस्टन्स इन पॅरलल, सिरीज पण आहे, नंतर घेऊया आपण. सो दिस इज कॉल्ड एज शंट रेग्युलेशन. सो दिस इज RSH. RSH. It is variable. So using this RSH, remember that this is your RL, this is load. The load will automatically vary. You are having some application, multiple lamps are there. You will go on putting the lamps, load will vary. Means here, I will not say you, somebody will put in the lamp, load will vary, and it is you who want to control. So what is your role? Your role is look at the voltmeter and control it. Is the idea clear? So what is shunt regulator? The most simple description of shunt regulator is that one variable resistor is put in what you are doing? You are calculating RSH. One variable resistor is put across the load, but that variable is a magic resistor. It operates in such a way that it tries to adjust itself so as to ensure that voltage should be 7 volts. म्हणजे असा एक रेजिस्टर की जो व्हेरिएबल रेजिस्टन्स आहे RSH आणलेला आहे की जो स्वतःला असं ऍडजस्ट करायचा प्रयत्न करतोय व्होल्टेज 7 व्होल्ट होऊ दे. समजा लोड बदलला, लोड वाढला, लोड व्होल्टेज ऑटोमॅटिक कमी व्हायला लागेल. ते कमी व्हायला लागलं की RSH स्वतःला वाढवायचं. So that magic cannot be so automatic, so it is you. So what is when I say that it adjusts itself, it adjusts means this, what is this resistor? This resistor, this is variable resistance. Variable resistance means what? There is some pot which position can change. The position of the pot can change doesn't mean that the position of the pot automatically changes. बरोबर का? फिक्स आहे म्हणजे तुला काही बदलायला स्कोप नाहीये. व्हेरिएबल आहे म्हणजे काय? पॉट आहे, त्याच्यामध्ये एक फिरतं टर्मिनल आहे. फिरतं टर्मिनल आहे मग ते आपण फिरत नाही. Somebody has to vary. So what is the magic resistance? This resistance which is having a variable position knob, but mere what you are doing, you look here. Don't look in the remote. That knob itself doesn't mean that it will be varying. The knob in your hand and you being attentive like all of you in the class. Otherwise, what is the use? If you are put here and you are expected, so what are you expected to do? What are you expected to do? You are, knob is there. When knob is moved on right hand side, shunt resistance increases. When knob is moved on left hand side, shunt resistance reduces. So how you should vary the knob? You should vary not randomly. Means mere having a variable resistance with knob, merely it is being held in your hand is of no use unless when the things are complete. When things are complete, unless your eyes are here. Unless your eyes are here, and with your eyes, what you watch the voltmeter. You watch the voltmeter. If voltmeter, what is expected, we have designed for 7 volts, right? So voltmeter is expected to show 7. If it is showing 7, then what do you do? Nothing. Let the position be as it is. If it is showing more than 7, you have to reduce till it becomes 7. And if it shows less than 7, you have to increase till it becomes 7. Right? So what is the logic with which means you do it? You have got a voltmeter with your eyes and using hand you do. But ultimately what you do means, can I say that you in attentive mode and the variable knob is a magical resistance which adjusts itself. लक्षात आलं का? नुसता पॉट आहे म्हणून उपयोगाचं नाही. पॉट आणि वर्गामध्ये नुसतं उपयोगाचं नाही. लक्ष असणारा विद्यार्थी म्हणजे असा ऑब्झर्वर की जो हे बघणार आहे आणि त्याप्रमाणे पॉट बदलणार आहे. सो अन अटेंटिव्ह इंडिव्हिज्युअल who is very much sincere in his operation and the scope is very limited. What is supposed to do? Look continuously, look at the voltmeter and adjust so as to keep it 7. Means the RSH is means this variable resistance with hand and watch, hand and eyes coordinated is a magical resistance, right? So magical resistance RSH adjusts itself. What are you doing? You are doing some research on magical resistance. RSH such that RSH parallel RL is this resistance upon RSH parallel RL plus R must be equal to what? Must be equal to 7 upon 10. Right? Is it clear? So 7 upon 10 means the simple operation of shunt regulatories adjust the resistance in parallel with load so as to achieve this formula, and it is in a cause-effect relationship. The load somebody else will vary, RL. Immediately RL should vary. So if we put the expanded formula, what happens? RSH parallel RL is RSH RL upon RSH plus RL upon RSH RL upon RSH plus RL plus R equal to 7 by 10. So multiplying numerator and denominator by RSH plus RL, we get RSH RL upon RSH RL plus R RSH plus R RL is equal to 7 by 10. Right? So in this case now, small r is known, RL is known. Known means at the current instant it is known. Right? So what is RSH? You have to find it out. Is it clear? That you can very easily. Now I think we should not waste time here. Is it okay? But the ultimate, what is the limit? Ultimate limit is that there is a minimum value of RL means maximum load value. I again repeat, minimum value of RL below which it can't go, because if an attempt is met, regulation will fail. म्हणजे एका ठराविक व्हॅल्यूच्या वर आपल्याला लोड घेता येत नाही. RL एका ठराविक व्हॅल्यूच्या कमी आणता येत नाही. What is the specific value? That depends upon these two values, and so you can find out RL has to be always more than equal to something which is related to 7, 10 and R. Is it okay? This is shunt regulation. This is shunt regulation. Now the question is it possible that every time for one regulator one person can be employed? One person will require one voltmeter, one knob and an individual. So that can't be done. So now जे तुम्ही करता, जे तुम्ही केलं असतं ते आपोआप करणारी काहीतरी यंत्रणा निर्माण करायला पाहिजे. सो वी नीड टू क्रिएट an arrangement wherein what the logic with which you were operating should be automatically done by a system, and for that Zener is a very important device. I will upload my 2 lectures on diode and transistor which will make the thing very simple for you. So Zener, how if you decide to study what is avalanche breakdown and what is Zener breakdown and try to conclude on that, your entire engineering studenthood will get exhausted in understanding how Zener breaks down. The breaking down of Zener is not so easily to be understood. Therefore, what we will do simply, this is cathode of Zener, this is anode of Zener. Zener is used in reverse bias. What is Zener? This is Zener. A, B, and this is VAB, and this is IZ or IAB. So VAB in the direction. So Zener voltage VZ is equal to VAB and IZ is equal to IAB in the direction shown. So what is Zener? Zener is the device which operates according to this. VZ and IC. This happens automatically, and or rather we will say not VZ IZ, we will say VD and ID. Means Zener diode is like a conventional diode which operates in exactly same manner in first quadrant and operates in a magical manner in the third quadrant, which is the normal quadrant of interest for Zener diode. So Zener diode is that device which maintains this characteristic. What is resistor? You know this is resistor, right? V and I, and depending upon resistor, the slope changes, right? So what is resistor? Resistor is a linear device. Resistor is a linear device where there is a linear relationship between voltage and current. Whereas diode is a non-linear device which is having this relationship between, and as regard in forward, you watch my lecture later on, in forward region the diode slope of Vi characteristic is very low and suddenly it increases and becomes very steep, almost vertical. Around 0.65 to 0.7, not exactly, around 0.65 to 0.7 volts. Whereas for normal, what you are doing, you are switching up Zener. For normal diode, in the reverse bias mode, it is going flat all the while at a very large value. Whereas for a Zener diode, which is like a conventional diode, third quadrant, it becomes suddenly steep at a general breakdown voltage. This is called as DC. And for different general diodes, the breakdown voltages are different. Conventionally available market are 4.7, 5.1, 6.2. Conventionally available ranges are 4.7, 5.1, 6.2. So these are the voltages where suddenly it means till that the VI characteristic is so interesting that it is very much horizontal, means it is again not to the scale, as good as horizontal up to 6.1, so 6.2 or whatever it is, up to 6.2 it is as good as horizontal, and immediately at 6.2 it becomes as good as vertical. General diode is providing me a characteristic almost horizontal and immediately vertical, and once this is IZ called as IZ min, means if this much reverse biased current is flowing, then the generator is ensured to be broken down. This is what I do if I have got this is 10 volts. This is a variable resistance. If this resistance is too high, what will happen? This voltage may be, if this resistance is too high, then this voltage may be this. When I go on reducing the resistance, what will happen? Please, now, if this is not the time, you watch the lecture and after exam, because this is the subject related to your domain, how will you find out? This is variable resistance, this is 10 volts, right? So it is variable. If I say 10 ohms, it can be 100 ohms, it can be 1k, it can be 10k, it can be 100k, anything. For different values of resistances, what will be the current? This Zener is having a graphical characteristic. This resistance is a linear device. So what you should have? This is VR, VZ, VD I can say. So because VZ is normally used as the rated voltage. VZ means there is, to avoid confusion, because VZ is normally called as the rated voltage. So 10 must be equal to VR plus VD. 10 must be equal to VR plus VD. And since it is series circuit, IR is equal to ID. IR is equal to ID, right? So now, using these two equations, and what is VR-IR relationship? VR is equal to R into IR. And what is VD-ID relationship? VD-ID relationship we don't know. But don't know means we don't know the exact equation, but we know the graphical equation. So can you solve graphically? अच्छा लगा? I think in high school you might have solved simultaneous equations graphically. Do you recollect? Solving two simultaneous equations graphically means what? Each equation you put the line and the cross section is the solution. What is the difference in that problem and this problem? In this problem, there are two equations which are the, one is decided by resistance, one is decided by diode. For resistance the equation is linear, but for diode the equation is non-linear. So this graph and a linear graph you can plot and you can think of graphical resolution. Right now we need not bother that much. We proceed for application of Zener for voltage regulation. So now I think we don't have that much time to ask a problem to you and expecting your solution. So we move at if this is 6.2 volt Zener, if this is 6.2 volt Zener, in 10 volt 1 ohm and IZ min is say 100 microampere. What is IZ min? IZ min means a minimum current which must flow. A minimum current which must flow through the Zener so as to keep the Zener in breakdown mode. A minimum current which must flow through the Zener to keep Zener in breakdown mode. And there is IZ max also, not so critical, but means it is the current which should not be exceeded, means to have Zener in good condition, the current reverse current through Zener should not exceed IZ max. It's not so important, but let us use it. IZ max equal to 5 amps. Let us say IZ max is equal to 5 amps. So this RS is to be used. RS is to be designed. So I will design RS. So this Zener, what is the use of this Zener? It's very simple. When there is load, R, right? So what will happen that here this is I, this is IL, and this is IZ. I is equal to IZ plus IL. I is equal to IZ plus IL. Now, what happens if this load resistance, and what is this VZ? Once I ensure that once I design this RS appropriately, this VZ is 6.2 volts. So this is 6.2 volts. So this is 10 volts. So 10 minus 6.2, 3.8. This is 1 ohm. If I choose this to be 4 ohm, total will be 5 ohm. So 3.8 by 5. So what it would be? 3.8 by 5? 7.0.76. Point or 760 milliamperes, right? 760 milliamperes. So when this 760 milliamperes is total current, so always 760 milliamperes will flow if this voltage is 6.2 volts. So if this RL increases, what will happen? I will reduce. But IZ will adjust itself. So you will say, what will happen? The reason is how it operates the regulator is in this characteristic. It's too flat, means if I say this IZ, so IZ is here, and what is VZ IZ we use interchangeably, means that 6.2 sometimes it is specified, but voltage, the characteristic being almost vertical, what will happen? That this Iz may increase or decrease. This Iz may increase or decrease. The voltage across zener will almost be same. लक्षात आलं का? म्हणजे कसं मराठीत सांगतो तुला, ते इतकं सोपं नाही कळायला, but if you attempt it is very easy. Actually, this zener itself is a magical shunt resistor. This zener is a magical shunt resistance, and this RS means, if you look it from different angle, in the first setting, what we were doing. This, your hand and your eyes was variable resistor. This zener is a magical resistor. Why? This VI direction is like this. So if you are operating at this point, this is current. This is voltage. So what is V by R? V by I. If you are operating this point, is it clear? So this is almost, but not exact, but almost vertical. This is almost what means this is 100 microamperes, and if it is say 100 milliamperes, over the variation of 100 micro to 100 milli, it is 6.2000 to 6. Just represent an example, not exactly. Okay, 6.203 काय सांगितलंय तर एक्झॅक्ट वर्टिकल नाही म्हणून. लक्षात आलं? So if at back down here when Iz mean is 100 microamperes, if voltage across is 6.2 volts, when Iz is 100 milliamperes, voltage across is 6.203 volts. So when voltage was 6.2 volts for 100 microamperes, what is the resistance? 6.2 upon 100 into 10 raised to 6 micro, right? Which is 6.2 into 10 raised to 4. 6.2 into 10 raised to 4, right? That is 62 into 10 raised to 3. It is 62 kilo. Is it okay? Effectively, this diode is non-linear. At given point of time, at this point, this diode behaves as a 62 kilo ohm resistor. Whereas at this point, what will happen? At 100 milliamperes, it is 6.203 upon 100 mil. So it is 6.203 upon 100, but milliamperes. That is 10. It is 62.03 ohms. So just see how it adjusts itself. So this magical, this is something what we exactly wanted, wherein it adjusts itself. So that means so this arrangement wherein a suitable, why is RS required to be put? This RS is required even if you don't put RS. There is chance that zener may get damaged, but right, good conditions are there, so that is not a major issue. Sometimes it is used to optimize the power dissipation, means to make the things efficient. But right now, these two, this R plus RS and the zener, there is a load. So this zener automatically works as a variable resistance such that voltage remains constant. So how will you calculate RS? be such that this should not be exceeded. RS should be such that this should not be exceeded. Means what? There is a value of Rx, and this should not exceed. This should not exceed means what? There should be some RS min. Means what is RS min? That, and this is when there is no load. There is no load, entire current will flow through zener. Means you have put the regulator and not put on the enable. So entire current will flow through zener. So what is the, in that what is I z? In that case, Iz is equal to 10 minus 6.2 upon R is 1 plus Rs. So what is that? 3.8 upon Rs plus 1 is Iz. And you should ensure that it should not exceed 5 amperes. It should not exceed 5 amperes. Means this must be equal to 5. So what will happen? 3.8 should be equal to 5 plus 5 Rs. Right? Or sorry, 5. The value itself by you're wrong. You should be. It's not possible. Let us say is 2. So 2 Rs should be equal to 1.9. So Rs is 0.9. If this is the value which is minimum, means Rs should not be less than this. So Rs min is equal to 0.9. What is Rs max? Rs max will occur. Rs max should be such that again Iz equal to 10 minus 6.2, and this should be actually, it should happen at Rs min. Rs min. Rs min. Rs min. And when it at Rs max, that time you must ensure that what should be the current? 100 microamperes. It is 100 into 10 raised to 6. So 3.8 upon 1 plus Rs max, sorry, raised to minus 6. It should be equal to 10 raised to minus 4. Right? Multiplying both sides by 10 raised to 4 is 3.8 should be equal to 1. So Rs max should be equal to 38 kilo. Rs max should be 38 kilo. But will it be only based on this? No. It depends upon also. So if we use, means this will only make this to work. We also should have this RL. We also should have this RL. So this Rs max will ensure that it will work as a Zener regulator. It will work as Zener regulator when there is no load. When you put the load, what will happen? You put the load. there is one simple and small problem with shunt regulator of Zener is that the Zener ratings are odd. So 6.2, 5.1, 4.7 like that. So we get those voltage regulators. So now if it is like this and let us say that RS is 1 ohm and this I put as 1 ohm. So RS max right now you ignore. This would be a 6.2 volts Zener. Calculate now calculate the range of RL till which it will function appropriately. Can you calculate? How? So this will work appropriately. This will means this will work. It will provide 6.2 volts. It will provide 6.2 volts across it. Till what time? Till what time? If you go on reducing RL, if you go on, so what we must have, so this is not so critical. So this IZ min 100 microamperes must flow. 100 microamperes must flow through Zener. If 100 microamperes don't flow through Zener, it will not work as a, it will not work in a breakdown mode. So it will, the voltage across that will not be constant. Means simply that current means if current reduces, then it goes to this region. The characteristic of Zener, if it is expanded scale, this is not to the scale, means this is 6.2 and this is say 6.203, but below means after this it is good vertical, wherein this must be 100 microamperes. If it is not 100 microamperes, if current is less, then it is not reliable constant. Means voltage, listen very carefully, voltage across a reverse bias Zener is almost constant provided that the reverse bias is maintained with a minimum reverse bias current called as IZ. If that is not maintained, the voltage across Zener is not constant. The Zener voltage reverse bias मधल्या Zener diode च्या across the voltage हे constant असतं as not exactly constant but as good as constant 6.2 volts, provided that the minimum breakdown current of 100 microamperes is flowing through it. If that is maintained, it will operate in breakdown. But if that is not maintained, it will not operate in breakdown. So in that case, everything will fail. So when we go for this one, this is 1 ohm, this is 1 ohm. So in that case, what is the value of RL? What is the maximum load? What is the maximum load which this regulator will be able to supply in a satisfactory manner? What is the maximum load means? What is the minimum RL below which it will fail? How much? 2.5? What? Ohm. How you calculated? RSH actually means it's not that it is not to be used like that. It's not wrong, but I will explain a simple, easily understandable idea. So, what it is? I is equal to what? Iz plus IL. I is Iz plus IL. Right? For this breakdown operation, what is I? 10 minus 6.2 upon 10 minus 6.2 upon 1 plus 1. That is 1.9 is equal to Iz plus I. 1.9 is equal to Iz plus IL. Right? Is it okay? Now, what is new in that? If RL reduces, what is IL? What is IL? 6.2 upon RL. 6.2 upon RL. So when RL reduces, IL will increase. IL will increase. Till what point IL should be allowed to increase? Till what point IL should be allowed to increase? Iz min must be maintained. Iz min must be maintained. So IL max is equal to 1.9 minus Iz min. 1.9 minus Iz min. Iz